So the first circuit I'm going to see is a flop with a asynchronous reset. So if you see here, this is the code for a flop. Always at passage clock. Always at passage clock signifies a passage flop. This signifies a passage flop. So always at passage signifies a passage flop. Okay. And also I am looking at passage of asynchronous reset. Okay. Now if you see, the moment I enter the always block, I'm first looking at if asynchronous reset. That means this clearly the if else, the if has more priority over the else part. That means first I'm looking for asynchronous reset. So in the Verilog code, we clearly know the always block will get evaluated whenever there's a change in the clock or there's a change in the reset. If there's a change in the clock or change in the reset, I am going into the always block. That's a positive clock edge or that's a positive asynchronous reset. And if I am entering the code because of asynchronous reset, I am making the queue go low. That means clearly whatever may be the name, I may name this signal as XYZ, anything. But upon this signal, the output is going low. Clearly, this is a asynchronous reset. Asynchronous reset. I'm calling this as asynchronous reset. Okay. And this is my output called Q. Else, if it was not for asynchronous reset, why did I enter this loop? It is because of the passage of clock. It's not because of clock. It is because of passage of a clock. That means, see, the clock has two edges. This is a passage. This is a neg edge, correct? If there is going to be a neg edge, this always block is not going to be evaluated at all. Only upon passage, I am going to enter into this always block. So only, that means clearly I am making the circuit sensitive to positive edge of the clock. Upon positive edge, Q is getting D. So this is a D flip-flop with asynchronous reset. Asynchronous reset. Why it is asynchronous reset? Because it is not looking for any clock. It does not await for a clock. So if I have a clock and if I apply my reset here, this is my reset, the output Q will go low irrespective of whatever it was here. Whatever it may be here, I don't know whether it's a 0 or 1, I don't know, but for sure after this point the output will be 0. And clearly it is not waiting for a passage of the clock. So that's why we call it asynchronous. It can happen anytime irrespective of clock. Asynchronous means irrespective of clock. Okay, this is the code for a D flip-flop with a asynchronous reset. Now if we want a asynchronous set, what we have to do, I am naming the signal asynchronous set so that the signals are named meaningfully. But I can call this signal as whatever. I can call this signal as alpha, beta, gamma also. That doesn't make anything. Look at the behavior here. If there is a asynchronous, so the always block is getting evaluated upon a clock or upon a asynchronous set. If I'm entering the always block because of asynchronous set, then I'm setting the Q to 1. So whatever may be the name of the signal, I am setting the Q to 1. That means without the dependency of clock, correct? Hence, I am calling this as a asynchronous set, else Q is assigned D. Now, if this is asynchronous set, how a synchronous set or a synchronous reset will look like? See, clearly, when I say synchronous, always understand that synchronous will come in the D pin of the flop. Whenever I say something as synchronous, whenever I'm going to say something as synchronous, it will turn into D pin of the flop. So how the synchronous reset will look like? This is my flop. It doesn't have a asynchronous reset. This is my reset. This is my synchronous reset. I have a mux. If the reset is high, it becomes 1 tick B0, else I load it with D. This is a synchronous reset. So clearly why this is synchronous reset? Clearly it is going to wait for the clock. So if this is my clock and this is my synchronous reset coming here. Now clearly the synchronous reset is fanning in on the D pin of the flop actually. So this 0 will be waiting here on the D pin and it will be awaiting the passage of the clock. So here on the subsequent next rising edge, whether the flop was 0 here or 1 here, I don't know, it will go to 0 here. So here clearly the reset is awaiting the clock edge, so it is a synchronous reset. And that is what is the behavior in the code also. So if you see the behavior in the code here, so please observe this code, and I want you to compare it with this code and observe. See clearly here in the sensitivity list, clearly note this. Here only clock is present, here clock reset both are present. Correct. Now that means this always block is going to get evaluated only upon clock. Even if the sync reset is going to toggle, it is not going to get evaluated till there is a passage on the clock. Upon passage of the clock, if there is a synchronous reset, clearly upon passage of the clock, I am going to see, look here now. Upon the passage of the clock, I look for the presence of, sorry, here. Upon the passage of the clock, I am looking for the presence of synchronous reset. If there is a synchronous reset upon the passage of the clock, I make the Q go low. Else Q follows D. This is clearly the behavior of a flop with a synchronous reset. Now, in some situations we may have both synchronous and asynchronous reset, and clearly we should have circuit to avoid race conditions in case we have both. See, asynchronous and synchronous reset will not cause race conditions, but if I have both a reset and a set, that may cause race conditions. We need to be careful there. See here, this is a flop with both asynchronous reset and a synchronous reset. Look at this code, how it looks like, and compare it with this code, please. I will put all the three codes side by side. Please compare it. In this code, if you see, I am evaluating the always block upon clock as well as upon asynchronous reset. Clear? Now, if I am entering the always block because of asynchronous reset, I make the Q go low. Else, the moment I write else, it was not because of asynchronous reset. If it was not because of asynchronous reset, that means the always block was entered because of a clock. Otherwise, the always block will never enter, right? We entered into the always block because of a clock, and upon the clock, if there was a synchronous reset present, I make the Q go low, else I assign the Q to D. This is a flop with both synchronous and asynchronous reset. It will look in the hardware like this. I have a flop, sorry, let me make it big. I have a flop. I have a asynchronous reset. I have also a synchronous reset. If the synchronous reset is going high, I'm making 0, else I'm connecting the D. This is how the flop looks like. So this is a flop with both sync and async reset. This is a flop only with asynchronous reset. This is a flop only with synchronous reset. Clear? This is clearly the distinction between these three things, and these are the coding styles. Okay. Thank you.